Welcome to Summarize Science. The James Webb Space Telescope has been finding something baffling in the early universe: massive galaxies with supermassive black holes that seem impossibly large for their age. How did these cosmic monsters grow so big, so fast, just a few 100 million years after the Big Bang? In a new paper, researchers investigate this very question using powerful supercomputer simulations. They created a detailed digital simulation of a massive galaxy forming at cosmic dawn, as seen in these incredible images. This allowed them to watch how a central black hole grows and interacts with its host galaxy under the extreme conditions of the early universe. The simulation zooms in from a huge cosmic scale right down to the turbulent heart of the galaxy. One of the key findings is that the black hole's growth isn't smooth and steady. Instead, it's a chaotic cycle of feast and famine. This is because the galaxy itself is a violent place, with intense star formation creating a turbulent, clumpy environment. All the energy from young, massive stars constantly churns the gas, which is the black hole's food source. The researchers found that this stellar feedback is so powerful that it effectively starves the black hole about 50% of the time. You can see this chaotic process in action on these graphs. Sometimes, the black hole finds itself in a dense stream of cold gas and feasts, growing rapidly. Other times, it gets stuck in a hot, diffuse bubble created by stellar explosions and starves. This feast or famine cycle, driven by stars, is the single biggest factor regulating the black hole's growth in this early stage. So, does the black hole's own energy output, known as AGN feedback, shut down star formation in the galaxy? Many would expect it to, but in these simulations, it doesn't. The reason is that the galaxy is constantly being refueled by massive filaments of cold gas flowing in from the cosmic web. This fresh supply of gas is more than enough to sustain star formation, even with a powerful black hole blasting energy into the galactic core. So how do we get the truly giant black holes that Webb is actually observing? The simulations show that to match reality, you need a special combination of factors. The black hole must be able to accrete matter at super-Eddington rates, meaning it has to eat much faster than the standard theoretical limit. At the same time, its own feedback can't be too efficient at blowing its food away, otherwise it would choke itself off. So let's recap the important points from this amazing research. First, stellar feedback creates a turbulent environment that forces the black hole into a feast or famine growth cycle. Second, the black hole doesn't quench star formation across the galaxy because the galaxy is constantly being refueled with fresh gas. And finally, to explain the monster black holes seen by JWST, they likely had to grow incredibly fast while being relatively inefficient at clearing out their own fuel supply. This work provides a compelling explanation for one of the biggest mysteries posed by the James Webb Telescope and gives us a new window into the chaotic dawn of our universe.